Almost every vehicle people drive today uses a hydraulic system. This system is utilized by the driver when they put a small amount of pressure on the brake to bring the vehicle to a stop. Many mechanisms occur within the hydraulic system to perform one simple action.
When a person steps on the brake pedal, it forces the piston inside the brake caliper to compress. As the piston plunges into the cylinder, the hydraulic fluid known as brake fluid is squirted through the pipe, which diverts into the four corners of the car. These pipes feed into much wider cylinders, which are positioned next to the car's brakes. Since the cylinders near the brake are much wider than the ones near the brake pedal, the force originally applied is multiplied greatly, causing the car to start stopping.
The main concept behind hydraulic system is Pascal's law. Basically, Pascal's law says that the pressure has to remain constant on all points of fluid. So, when a person applies a small force on a brake pedal, the area of the master cylinder is very small, and the pressure has to remain constant. Therefore, the force applied near the brakes will become much larger because the area of the cylinder near the brake is much larger.
To put this concept into a simple example, say a 2,000 kilogram car is going at an initial speed of 15 meters per second and comes to a complete stop in 8 seconds. Using F equals mass times acceleration, we know that the total force to stop the car in this time equals 3,750 newtons. Say this force is distributed equal to all four brakes. Therefore, the force required per brake is equal to 937.5 newtons. Pressure must remain constant throughout the entire system if each of the brake cylinders has a surface area of 10 meters squared and the master cylinder has a surface area of 1 meter squared. We know from Pascal's law, the driver only needs to apply 93.75 newtons of force to stop this car.
The fluid most commonly used in this type of system is a mineral oil or glycol-based oil, as these types of fluids fit the criteria needed in order for this system to work properly. This type of fluid needs to have a very high boiling point and a very low freezing point, as the temperature of the car can experience a variety of temperature ranges. The fluid must also have a consistent viscosity throughout a wide range of conditions so the system functions the same in whatever situation the user may encounter. Finally, this fluid needs to be anti-corrosive to limit wear and tear on the system as the vehicle ages. The braking system of a vehicle is essential to its safety and must be reliable throughout the entire life of the vehicle.
Analysis of the brake system specifications and the fluid mechanics shows us that the hydraulic brake system effectively multiplies the force applied by a driver's foot by 40 times. By using the appropriate measurements and equations, a small amount of force applied to the brake system translates into a very large force that could bring a 40-ton truck to a complete stop in mere seconds. This simple, yet effective mechanism plays a large role in our everyday lives, allowing for both safe and effective performance in drugs.